Where is everyone? The universe is nearly 14 billion years old. There are over 100 billion galaxies, each with billions of stars and likely trillions of planets. If life is common, if intelligence is inevitable, then we should be seeing something. Signals, visitors, evidence, and yet silence. This contradiction between high probability and zero evidence has a name: the Fermi Paradox. But here's the real question. What if we're not alone, but we're not ready for what's out there? This isn't just about aliens. It's about us. About where we're heading as a civilization, as a species, maybe even as data, because understanding why we haven't found intelligent life might reveal the future we're blindly racing into. Do we become the signal that never arrives, or the silence that follows? In 1950, physicist Enrico Fermi asked a deceptively simple question over lunch. Where is everybody? He was referring to intelligent alien life. Given the age of the universe and the sheer number of stars, it seems statistically impossible that Earth is the only place with sentient beings. Carl Sagan echoed this in the 80s. The universe is a pretty big place. If it's just us, it seems like an awful waste of space. And yet, despite decades of radio telescopes, deep sky surveys, and interstellar probes, we've found nothing. No voices, no signals. Just cosmic quiet. This is the Fermi Paradox. The universe should be teeming with life, but we see none. In 1961, radio astronomer Frank Drake created a simple yet profound formula, the Drake equation, a way to estimate how many intelligent civilizations might be out there. It multiplies cosmic variables, like the rate of star formation, the fraction with planets, the number that might develop life, intelligence, and technology. Even with conservative numbers, the answer isn't zero. So if life should be out there, where is it? Imagine an ant colony in the Amazon rainforest. One day, a highway is built nearby. Cars rush by, planes soar overhead, skyscrapers rise. They never notice. Their world isn't equipped to detect ours. Now flip it. What if we're the ants? One possibility is we're special. The rare Earth hypothesis says intelligent life may require a perfect cosmic cocktail, a stable star, a protective moon, a magnetic field, plate tectonics, liquid water, and billions of years without annihilation. Maybe Earth is a lottery winner, and we're alone because life is astronomically rare. But that answer feels just a little too convenient. Another possibility is more unsettling. It's called the Great Filter. The idea? Somewhere between stardust and starships, there's a wall, a barrier that almost no life crosses. Maybe life is common, but intelligence is rare. Or maybe intelligence emerges and then destroys itself. Nuclear war, rogue AI, environmental collapse, self-inflicted extinction. The scariest part? We don't know if the Great Filter is behind us or ahead. If it's behind us, we're rare. A miracle. If it's ahead, we're just waiting for our turn. Today, projects like SETI, Search for Extraterrestrial Intelligence, and Breakthrough Listen are scanning the stars, not for aliens themselves, but for signals they might leave behind. They listen for narrowband radio waves, laser pulses, industrial gases in distant atmospheres. In 2023, scientists proposed searching for technosignatures. Things like Dyson Spheres, massive structures that could surround a star to harvest energy, or artificial light on the night side of a planet. Astrophysicist Sara Seager has led frameworks to detect such signs, proposing that biosignatures and atmospheric chemistry might be the breadcrumbs of distant life. And yet, we found nothing. Every star is intact, every signal empty. Physicist Kardashev once imagined a scale. Type 1 civilizations harness planetary energy. Type 2 can harvest all the energy of their star. Type 3, the energy of an entire galaxy. We are not even Type 1. But what if the silence is intentional? The zoo hypothesis suggests that we're being watched, observed. Like animals in a cosmic nature preserve, untouched, undisturbed, studied. Maybe there's a rule. No contact until a species crosses a certain threshold. A test we haven't passed. Or maybe we haven't even understood the test. We're not invited yet. We might not even know there's a door. In 1974, we sent the Arecibo message, a 3-minute binary greeting beamed toward a distant star cluster, a mathematical whisper to the cosmos. 3 years later, in 1977, a powerful radio burst was detected by Ohio State University's Big Ear telescope. It lasted 72 seconds. One blip, never repeated. Astronomer Jerry Amon circled the printout and scribbled a single word, "Wow." To this day, we have no idea what caused it. A cosmic wrong number? Our only hello? Here's another problem. We assume aliens would use radio, or lasers, or even bodies made of carbon. But what if advanced civilizations don't send messages? What if they become them? Post-biological life. Digital minds. Planet-scale AIs evolving beyond matter and time. We might be missing the signals entirely, not because they aren't there, but because they aren't meant for minds like ours. The silence isn't just absence. It's a mirror. If no one has colonized the galaxy, maybe we will. Or maybe civilizations burn out faster than we think. Maybe cosmic ambition is always outpaced by self-destruction. Our future might hinge on which is true. Stephen Hawking once warned us, if aliens ever visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. Sometimes silence is safety. So where is everybody? Maybe they're extinct. Maybe they're hiding. Maybe they're waiting. Or maybe we're first. Which could be the most terrifying answer of all. If that made your neurons fire, subscribe for more big questions with real-world edges. This is Theory Spark.